Three different types. Three different types, three different categories. Shifts. Say it again. Yes, of course. I'm sorry. Forgive me. The not function symmetric with respect to the origin. Shifts. Of course, there are two types. Horizontal, vertical. Reflections. Two types with respect to the x-axis and with respect to the y-axis. I'm going to write WRT with respect to the x-axis or the y-axis. Last category, stretching, shrinking. Stretching, shrinking of two types, horizontal, vertical. After we analyze each and every one of them, this will be the end of the material for test 1. Okay, so let's start with, I'm going to call them 1, 2, 3, 4, so I don't have to go back. I'm going to call this 5. I'm going to leave this one for the last, and you'll see why. 1, 2, 3, 4, 5, 6. Good. So let's start with number 1. Horizontal shifts. Okay. Let's suppose I'm given a function f, which is x plus 3 everything squared. I'm also given a function g, which is x minus 2 everything squared. Forget about function g for a moment. I'm going to cover it. And I'm going to ask you, let's look at function f and analyze, or I'm going to ask you this question. Which function from all these types, we had 1, 2, 3, 4, 5, 6, 7 different types. Which of these 7 types, basic functions, basic 7 functions, was used, I used to create the function x plus 3 squared? Quadratic, very good. So obviously I will say the base or basic function is x squared. Now, where will this graph of x plus 3 go? So let's analyze this. So this is x squared. Where is the vertex, or where does it cross the x and y intercept? Of course, at the origin. Now the question is, does this graph go 3 units to your left or goes 3 units to your right? Before you answer, remember, when x is 0, y is 0 for the base function, if I move it to 3 units to your left, what will be the vertex now? Negative 3, 0. If I move it to the other side, what will be the vertex? 3, 0. Which of these two will, the negative 3, 4x or the positive 3, 4x will give us the x-intercept? Will make y still be 0. Because if I plug in 3, 3 plus 3 is not 0. But if I plug in negative 3, negative 3 plus 3 is 0, and the graph stays on the x-axis. If I think that it moves to the left, to your right, then I will have to plug in 3 plus 3. I don't get 0. So it goes somewhere else. But if I plug in negative 3, the graph stays on the x-axis. Negative 3 plus 3 is still 0. So what kind of shift is this when I change x into x plus 3? Where does the graph go? to the left, exactly, to the left 3. So this is a left shift of 3 units. It starts, we're going to graph this in a moment. It starts at the origin and it shifted 3 units to the left by changing x into x plus 3. Okay. Where does this go? Again, we're going to graph them in a minute, both of them, and the base function. Where does this go? Remember, it starts at 0, 0. If I want to move it to the left, the negative 2 minus 2 has to be 0, which is not, in order for it to stay on the x-axis. So where does this go then? 2 to the right. So this is a right shift of 2 units. Right shift of 2 units. Now let's graph all 3. When I'm asked to graph using transformations, I'm not really asked to graph an accurate graph. I'm asked to graph, show me this quickly. So in order to show this quickly, I will start with the base function, which is this. This is the x squared. Then you told me that x plus 3 moves 3 units to the left. I'm going to do just that. This is x plus 3 squared. And then the last one, you told me to move it 2 to the right. I'm going to just move it 2 to the right. So this is the x minus 2 squared. Again, if you're wondering, where is this useful? Here's an example. If we're having, and I'm going to show you a very interesting problem in your book. I really enjoyed this problem. So for example, they're measuring the heights of kids. It can be girls, boys, doesn't matter. So they're measuring them at 10 months and 20 months and for the height. Okay? So you see this. When we plot all those ordered pairs, will I think of a linear function? No, I'm not going to think of a linear function. Will I think of a quadratic function? No, I'm not going to think of a quadratic function. Will I think of a absolute value? No. What could I think of? What type of function does something like this? The square root. So if I don't know, of course, there's going to be a shift, there's going to be a stretch, it's going to go up. So I need to understand the transformations in order to figure out what the data are telling us. So these are horizontal shifts. And I will write myself a note here. X changed into x plus 3 or x minus 2 as an example. The x plus 3 is a left shift. The x minus 2 is a right shift. Now we're looking at number 2. So for number 2, I'm going to pick other functions. I'm going to pick f of x equals the absolute value of x minus 3. I'm going to pick g of x, the absolute value of x plus 1. And again, like before, I'm going to ask you, what base function did I use to create these 2 new functions? I used the absolute value. Perfect. Now, I'm asking my next question is crucial. Am I changing, have I changed x or y? So the base function, y equals the absolute value of x. So did I change x? Or did I change the y value adding and subtracting from it? This is the y value. Am I changing the y or I'm changing the x? Because if I'm changing x, I have to do this. If I'm changing y, I have to do this. I am changing y. There is no change from the base function to any of these 2 functions in x. The change is outside. So where do you picture this? Where, after I graph the base function, which is the absolute value of x, where will you picture this? So that's my absolute value of x because we know the basic functions. So where will I graph f? How many? Yes. Negative 3, down 3, completely parallel. Completely parallel. My graph is not perfect. Forgive me. It's not going to be perfect. So this is the absolute value of x minus 3. Where will I graph the absolute value of x plus 1? Indeed, completely parallel, up 1. So this is the absolute value of x plus 1. Awesome. So this is my number 2, vertical transformation, right? Up or down, but I'm changing y. Y is changed. Y is changed, either up or down. So I'm going to look at now at the reflections. Number 3 and 4 together. Now I'm going to pick f of x as the square root of negative x. I'm going to pick g of x as the square as negative the square root of x. Okay, again the same question. Which function did I use to create these two new functions? Yes, I used the base function, the square root of x. Perfect. Now, the next question is, I have to identify what I changed in each. So, let's analyze the first one, f. This is the square root of x, and this is the square root of negative x. What am I changing? I'm changing x. So here's what happens when I change x. When I change x from positive x to negative x, from positive 2 to negative 2, or from negative 5 to positive 5, what am I doing to the graph? I am reflecting it with respect to, that's it. So this is a reflection, WRT, with respect to the y-axis. I'm changing x into the opposite. Let's graph this for a moment and then come back to G. And I thank Walmart for my colors, because I would have not been able to show you without colors here. So this is, as we know, the square root of x. And this will be, I can never completely graph this symmetric. For some reason on this side I can. So you know what I mean. It's not going to be perfect. So this is the square root of negative x. So I reflected the graph of the square root of x with respect to the y-axis from positive x to negative x. Perfect. Now let's come back to the second one. And let's analyze what I'm changing for the second one. Here's what I'm changing. Square root of x does not change. Square root of x does not change. Am I changing x or am I changing y? I am changing y. And now let's be careful. When I'm changing y from positive y to negative y, or from negative y to positive y, what is this? Exactly. So this is a reflection, WRT, with respect to the x-axis. So the green graph that I have here, which is the square root of x, this time reflected with respect to the x-axis will be this, negative the square root of x. Now, I would like to stop for a moment and give you an example of a combination. Let's look at the combination. So let's say I want to graph f of x, which is negative the absolute value of x plus 2 plus 3. How many transformations are in this function? All of them. Everything that we've studied so far. Exactly. And I have to present them in the order of operations. as if I were to evaluate this function. What do we do first? If I say plug in 5 in this function, what operation would you perform first? Plug in 5. What would you complete first? 5 plus 2. Then you will apply the absolute. Then you will flip. And then you will. Exactly. It has to be in that order. You cannot say that I move up and then shift to the left and then multiply. No. It has to be in the order of operations. You have to say x plus 2 first, multiplication by -1, which is a left shift, multiplication by -1, which is a horizontal, which is a reflection with respect to the x-axis, and then up to it. That's the correct order. So I will say, what is the base function first? That's my first step. Yes, base is the absolute value of x. First transformation is on the absolute value of x. Can anyone give us the first transformation on the absolute value of x? The absolute value of x plus 2, right, is the first operation. Yeah. Good. The second step is a transformation on number 1. What operation will I perform on number 1 to get the next step? Very good. We'll write in a minute what this means. And number 3 is a transformation on number 2. What is the transformation on number 2? Final step. Yes. So this one is shift where? Left 2 units. Very good. This one? Reflect? Yes. With respect to? Very good. Because I'm changing y. It's outside. And the last one, indeed, up 3. We decompose this function into very, very simple steps. So let's graph it. I will graph all steps. First, I graph the absolute value. That's the base function. Then you told me to shift left 2. That's what I'm going to do. Shift left 2. Then you told me to reflect with respect to the x-axis. And then you told me to shift this up 3. 1, 2, 3. This is the last graph, negative the absolute value of x plus 2 plus 3. Of course, this is a rough estimate in the sense that I did not determine the x and y intercepts. I did not do any groundwork. You're just saying, show me this function quickly. And this is what I would do. Okay? Let's go back to the last 2 transformations. We'll start with 5 and then we'll go to 6. F of x equals 2 times the absolute value of x. And g of x equals 1/3 times the absolute value of x. First of all, I have to ask myself, what function did I use? Very good. Absolute value indeed. Second question is, forget about g for a moment, and let's look at f and decide whether we are changing x or we are changing y. And you only have to do look at and compare them and see if there is a change close to x or a change outside. If it's a change outside, is y. If it's a change next to x, it's a change in x. It's a change in y. Very good. Good. So when I graph the absolute value of x, here's what I get. And then you will tell me, how do I graph 2 times the absolute value of x. So let's analyze for any x value you want. So let's say for x equals 2, what is the y value here? 2. But now, for x equals 2, what will be the y value for function f? Very good. So the x value for function f will be this. So here is what happens. So what have I done? The shape is no longer the same. Remember, all transformations from before kept the shape intact. This time I'm telling you this. This is the original function, and this is the new function. The shape is no longer intact. The idea is the same, but it's not exactly the same function, right? The same graph. It's this. We call this a vertical stretching. Vertical stretching, in this case, by a factor of, exactly, vertical stretching by a factor of 2. Let's analyze G. What am I changing in G? Am I changing x or am I changing y? Y. Now let's analyze what happens. So when I get to 2, when I plug 2 in here, what will I get? So this particular height will be multiplied by 2, or it will be divided by 3. Yes. So this time the original graph is this, and 1/3 the absolute value of x will be this. We call this a vertical shrinking of the graph by a factor of, yes, vertical shrinking by a factor of 1/3. Because I chose 2 and 1/3, but you know what I mean. If it's a ratio less than 1, it will always be a vertical shrinking. If it's a number greater than 1, it will always be a vertical stretching by a factor of 1/3 in this case. So let's graph that function as well. So here it is. I divide this by 3, and this is this point. So this will be 1/3 times the absolute value of x. Okay. We have only 4 minutes left. I don't think I can finish that last transformation, but we can leave it for the next test. I still would like to review. I will bring on Wednesday, I will bring a previous test, and we'll work on that test from the beginning till the end. So I will finish this, but the last one, the last transformation is not going to be on this test. We can move it to the other test. I feel I'm so behind. Okay, say it again. The test is on Monday. From everything we studied except the horizontal stretching and shrinking. That can wait because I don't think I can finish in 3 minutes and I don't want to rush through it. Okay, so let's look at a problem from your book and then we can stop. For example, problem 80, last thing, f of g of x, 80 on page 295. Equals 2 times the square root of x plus 1 minus 1. Okay. We're asked to complete a graph or present a graph that uses transformations. No one will look at the graph with a magnifying glass. It's just a shape, an idea of the graph, which is quite accurate, but the points will not be accurate. That's what I mean. Okay, so first I have to identify what base function was used here. Very good. Now you can begin to see that pattern. Okay, number 1 is a transformation on the square root of x. What transformation on the square root of x is Step 1. I cannot do up and 1. So first of all, careful. What am I changing from this to this? Am I changing x or I'm changing y? Good. So first I have to say the square root of x plus 1, which is not up and down. When I change x from x plus or x minus is this, right? So this, what happens here when I change x into x plus 1? Very good. Awesome. Left one indeed. The next transformation is on number 1. Now this is gone. This is on this. In order of operations, what will be the next step? Yes, 2 times the square root of x plus 1. Now I'm asking myself, is it a change in x or a change in y? It is a change in y, meaning like this one, from the absolute value of x to 3 or 2 times the absolute value of x. So what will this do to the square root of x this time? Very good, very good. Vertical stretch by a factor of 2. And the last step to create the entire function is a transformation on number 2. So it's 2, the square root of x plus 1 minus 1. So now this doesn't change. Okay, so it's an outside change. So what am I changing from this to this? Indeed. So what does this mean? Very good. Shift of down 1. So now let's graph. I ran out of paper, so here it is. And this is it. So I have to graph. Start by graphing the base function. Let's do just that. I know it's 3:15. I'm so sorry. Just allow me to finish this 1 second. So this is the absolute value of x. And then I have to shift the graph as you told me 1 to the left. Here it is. Here's the graph of the square root of x plus 1. You told me to stretch this graph. I'm going to take just this unit. I'm going to say this has to be doubled. This piece has to be doubled. So I'm going to graph this as twice the square root of x plus 1. And then you told me to shift all this down 1. So I'll shift it here. So this is negative, I'm sorry, it's 2 the square root of x plus 1 minus 1.